Slope-intercept form of linear function. So slope-intercept form is in this form of y equals mx plus b. And you probably already had experience with slope-intercept form from your pre-algebra class. But it's called slope-intercept form because m is the slope and b is the y-intercept. So, I mean, it's kind of slope y-intercept form, but that's why it's called slope-intercept form, because it gives you the slope and it gives you the y-intercept. That's why it's called slope-intercept form. So number one says, write the equations of the following graphed linear functions in slope-intercept form. So we need those two things. We need the slope and we need the y-intercept. So I'm going to just kind of plot the, so the I'm going to do the y-intercept first. I like doing that first. So the y-intercept's at 1. Okay, so we know the y-intercept's at 1. So maybe I'm going to write it out maybe here for the first example, but at some point it'll become kind of elementary. So our y-intercept is 1. So our b is 1. Our slope, remember, slope is defined by the change in y divided by the change in x, or our rise over our run. So I have that nice y-intercept point. Another nice point that crosses nicely is right there. So the rise is up 2 over 1. So our slope is 2 over 1, and 2 divided by 1 is just 2. So I'm going to underline that because this is the stuff we're going to be using for the equation. So in y equals mx plus b, our slope is 2. So we're going to have 2x plus our y-intercept of 1. That's the equation for that one. Let me show you b. I like to get the y-intercept first. It's 5. So I know our b is going to be 5. Then our slope, got to pick another nice point that crosses well. I don't see one until here. So if I look at the slope, it's going down. And this is all the scales are just by 1. If you haven't noticed, it's going 1, 2, down 3 over 4. So down 3 over 4. So our slope is negative 3/4. Now that does not divide nicely. You're going to get negative 0.75. So I'm just going to leave it as negative 3/4. So I'm going to say y equals negative 3/4 x plus 5. Remember, y equals mx plus b. So I'm using that template up there. Y equals mx plus b. I'll let you try C and D. So number 2 says graph the following equations written in slope-intercept form. So with A, I know the y-intercept is negative 2. Remember, we're using, just write it for the 100th time, y equals mx plus b. M is our slope. B is our y-intercept. And you always want to start with the y-intercept, our b. So our y-intercept is negative 2. So we're going to start at negative 2. And our slope is 3. Now our slope is 3. Now, if we're trying to do rise over run, it's easier to write it as a fraction. So if it's 3, I'm going to write it as 3 over 1. So that means I'm going to go up 3 over 1. So from the blue point. So I'm going to go up 3, 1, 2, 3, to the right 1. And I always go to the right. It's a positive slope. So always that if it was a negative 3, would it go down 3 to the right? Since positive 3, we're going to go up 3 to the right. So up 3 to the right 1, up 3 to the right 1. Okay, that's good enough. B, the y-intercept is 4, positive 4. And the slope, there's no coefficient here, it's negative 1. Okay, it's just like negative 1. There's no coefficient. Remember, if there's no coefficient on the x, it's just like a 1. There's a negative in front of it, so it's negative 1. And I'm going to put it over a fraction again because it's going to be helpful. Negative 1 over 1, so that means I'm going to go down 1 over 1. Down 1 over 1, down 1 over 1. That's what I'm doing there. Good enough. Now with C, I'm going to let you do C, but careful because it's kind of written backwards. This is really like negative 2x plus 5. Just be careful because whatever's attached to the x is your slope. So just be careful with that. So that one, I'm going to let you do. The y-intercept's positive 5. The slope's negative 2. So you're going to go down 2 over 1, down 2 over 1. I'm going to do D, though. So the y-intercept's negative 3. And the slope is 1/2. So that means go up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. I'm going to continue the pattern this way. And when you're graphing, always make sure your slope is going the correct direction. Like this is a positive 1/2. So look at my arm. It should be going positive, going up when you read it left to right. If yours, that would be negative slope. The positive slope's going like up, right? Negative slope is going down. So just always look back at your answers. Like, on A, it was a positive 3 for our slope. So that's why it's slanted upwards. On B, it was a negative 1 for our slope. That's why it's slanted downwards. Hopefully you remember that from pre-algebra. Let me do another one, E. This one, the y-intercept's negative 4. And the slope is 3 over 2. So that means we're going to go up 3 over 2. Up 3 over 2, and that'd be here. Up 3 over 2. Let me put another dot down here. I just draw. You only really need 2 dots to make a line, but I want my line to look decent, so I try to graph kind of as many as I can on the coordinate plane. So y-intercept's negative 4, slope's 3 over 2. So we went up 3 over 2, and it's positive 3 over 2, so slope's positive. So our line is, again, if you look at my arm, it's going, when you read it left to right, it's going up. Should be good there. Okay, I don't want to do too many for you, so I'm going to let you try the other ones. Now, I and G, these last 4 are kind of like unique cases. So let me show you I. So this one just says y equals 5. There's not even an x on this. Not really even y equals mx plus b form. If you were to have an x on it, it would be like a 0x because it's not even there. 0x. So there's actually no slope. We're basically just like a y-intercept of 5 with no slope. It's just a flat line. A horizontal line to be more specific. The way that I like to think about it a little bit more, if it's y equals 5, every single point on this line has a coordinate of 5 for y. Right? Like this point here is 1, 5. This point here is 1, 5. You don't have to write this. This point here is 2, 5. This is 3, 5. This is the line that literally every single point on it, y is 5. So, yeah, y is 5 on that line. So when you have like that, y is like, can be like that. X equals negative 2. Now this one's different. So to think of this, okay, where is x equals negative 2? Well, right here. Our x-axis, this is where x is negative 2. Well, x is negative 2 here as well, and here as well, and here as well. X is negative 2 all along all of these points. That's where x is negative 2. So this is the line for x equals negative 2. And it's weird, like that's the line for x. That's actually not even a function, right? That's not even a function, but that's the line for x equals negative 2. So when you have an x equals equation, it's a vertical line, which is kind of counterintuitive because our x-axis goes this way, so it's kind of confusing. But just think of it like logically, x is negative 2, right here, and x is negative 2 on all these points. So when you have an x equals equation, it's actually vertical. And when you have a y equals equation, like on I, it's actually horizontal. Okay, so I'll let you try those ones there. Now, let's look at some tables. So we're still trying to write these in slope-intercept form, but now we're looking at it from a perspective of a table. So let me do A. So in order to get the y equals mx plus b. Remember, we just need two things. We need the slope and we need the y-intercept. So the y-intercept, this is an important concept to understand. The y-intercept is always, and it says up here, the y-intercept is where x equals 0. If you think about a graph, and I could go up to those previous graphs up there. Maybe I will. If we think about the y-intercept, all these y-intercept, this is at 0, -2. This is at 0, 4. This is at 0, -3. The x value on the y-intercept, for the y-intercept, another one, 0, -4. The x value for the y-intercept, regardless of where it is on this axis, is 0. So our y-intercept is always where x is 0. So on 3a, our y-intercept is 7. Because where x is 0, we have 7. So we know our y-intercept 7. So we're good there. Now we just need the slope. Change in y divided by change in x. So our slope looks like it's going +6, while the x is going by 2's. So our slope would be, I'm going to use m again, 6 divided by 2, which is 3. So our equation be y equals mx plus b, or their slope is 3, so it's going to be 3x plus our y-intercept we said was 7. That's the equation for the line. And we can always test our equation out. For instance, don't write anything I'm writing, but if we plugged in 4, I'm just highlighting 4 here, to that equation for x, 3 times 4 is 12, plus 7 is indeed 19. Our equation works. Even if I plugged in 6, 3 times 6 is 18, plus 7 is in fact 25. Our equation works for our line. So always check that. Oops. Okay. Let me do C. Again, I like to find the y-intercept first, and we look where x is 0. X is 0 right here. So we know our y-intercept is -4. Now we just need the slope. So it looks like this is going plus 1.5. And it's doing that each time. Since it's linear, I don't really need to, it's telling us it's linear. We don't really need to do all of them, but it's going up 1.5 for every time. It's just going up by 1 in the x direction. So our slope, 1.5 divided by 1, is just 1.5. So our equation would be y equals 1.5x. And our y-intercept is -4, so I'll write -4. Let me show you D. Now D is a little bit tricky because if we're looking for a y-intercept, I don't even see the 0. There is no 0 for x on this table. So we're going to hold off on that. Let's just first get the slope. It looks like it's going down 4 as this goes just by 1s. So our slope, -4 divided by 1, is -4. Now, we have our slope. We just need our y-intercept now. Now, remember the y-intercept is when x equals 0. But it's not on this table. So let's do some backtracking. If I were to go back to 0, I'll try to like squeeze in a 0 here, create a new entry in the table. The question is, if I went this way, what would the y value be? Well, we see it's going by 4s, right? So if I take away, I need a number that if I take away 4, I'm going to get to 5. Well, that would be 9. Because that would kind of show the pattern going down 4. So when I'm going back up, I would have to go plus 4 from the 5. So the y-intercept's 9. So you have to do some backtracking, some logical thinking when the x is not shown. You got to go find it. So I can tell here that that would have to be a 9 at x is 0. So in my equation, slope was negative 4x, y-intercept is 9. And there you go. Maybe let me talk about E really fast. So in E, this is going down 2 by 3. So our slope will just leave as negative 2/3. And of course, our y-intercept is 15. That one's given to us. So, and I don't know if I needed to do that one for you, but you could do negative 2 divided by 3 to get like a decimal or something like that, but it's going to be repeating. So we'll just leave it as a fraction. But yeah, I didn't mean to do 4 out of the 6, but hopefully that's helpful. Okay. I'll let you do everything else.